Vertical projectile motion question 3. Start on a new page. The position time graph for a tennis ball thrown vertical upwards from the second floor of a building is shown below. Ignore all effects of friction. Right, you can look at the graph. The height of the second floor is 6.5 meters. The ball rises 0.9 meters from the point of projection before it starts to fall to the ground. Then question 3.1. Suggest at this point you pause the video, then you can attempt the question yourself. Right, 3.1. Write down the magnitude and direction of the acceleration of the ball while it is moving upwards. This is a question that examiners like to ask, and this is a very common question, but it has a simple solution. As long as an object is a projectile or is in free fall, that means it's in motion due to the force of gravity only, and the acceleration of that object is always 9.8 meters per second downwards. So our solution to number 3.1 is going to be 9.8 meters per second squared downwards. Always, we are not going to have it any other way. There is no way you can say it's 9.8 meters per second upwards. No, because the force of gravity is always acting vertically downwards. Question 3.2. Calculate the time t it takes the ball to reach its maximum height. I want to say that this is quite a difficult question, but it looks so simple it might be difficult, but let's look at it. Mostly we list our data. So in this case, I'm going to say, I'm going to take downwards as positive, and I'm going to list everything that I have. Right, initial velocity I do not have. Final velocity, if I'm going to calculate up to this point, let's call this point X, it's going to be 0 at the maximum height. Do you see that? Gravity, I'm going to use a positive 9.8 meters per second squared, and the displacement, I'm going to use a negative 0.9 meters as it is being displaced upwards. Now if you look at this and you check for an equation to work with this one, it's going to be quite difficult to work with this one because you are looking for time, and this information might be quite challenging for you to get an equation to use. So this is how I did it. I changed everything and I said, I know the time to move from this point X, let's say, to this point Z, is the same as the time to move from that it takes the object to move from the point it is thrown to get to maximum height. Right, so I'm going to change everything. I'm going to use this information to move from point X to point Z. I'm going to say the initial velocity, still taking downwards as positive. I'm going to take my initial velocity as a 0. This thing is going to be falling, and as it falls, I'm not going to use its final velocity. I'm going to use the change in y as a 0, and I'm going to use the gravity as 9.8. Then I calculate the change in time. The change in time that I get is the same change in time here. So that's one way of doing it. That means I need to use the equation that says change in y is equals to initial velocity times change in time plus half the acceleration times change in time squared. Right, change in y in this case is going to be 0.9 is equals to the initial velocity 0 multiplied by the change in time plus half of 9.8 multiplied by change in time squared. Now if you solve this equation, you're going to get to a point where you have 0.9 is equals to 4.9 times change in time squared. You divide 0.9 by 4.9 and then you find the square root. You get the change in time is 0.425. Right, so 0.425 seconds is the time it takes to move from point X to Z. But remember, it's also the same time it takes to move from this point to X. So we now know that this is 0.425. That will make this one 0.8. Double this value is going to make it 0.85. So we have solved the question on time. So calculate the time it takes the ball to reach the maximum height, which is time t. I'm going to write my answer here as 0,425 seconds. Just going to pause the video now. Okay, now we move on to question 3.3. Calculate the initial velocity of the tennis ball the instant it is released. This one is going to be easy because we already have the data that we have written here. We are using v initial, we don't know it. V final, we know it's going to end at 0. Gravity at 9.8 and change in y. We're going to use negative 0,9. So we're going to use this information to calculate the initial velocity, and the best equation to use here is going to be v final squared is equals to v initial squared plus acceleration plus 2 times acceleration times change in y. We know the final velocity, it's 0 squared. So now I'm actually using this information from this point, which I'm going to call point q, up to point q up to point x. So v initial is the one we are looking for, v initial squared plus 2 times the 9.8, multiply it by a negative 0,9. Remember, I'm taking downwards as positive and using this information here. Now solving this one, you end up seeing that v initial is going to be 4,2. The answer you get, remember, when you multiply this one, you're going to get it the other side. We'll move it the other side, then we find the square root. Remember, when you find the square root, the answer is going to have a plus and a minus. In this case, you will get a 4,2 meters per second. You must remember 4,2 meters per second. Remember, it's upwards, so it's going to be 4,2 meters per second upwards. That is the initial velocity of the tennis ball, 4,2 meters per second upwards. Right, then number 3.4, they say sketch a velocity time graph for the motion of the ball from the moment it is thrown vertically upwards till it reaches the ground. Label the x-axis, show all the relevant values on the graph. Right, I'm just going to quickly erase this, so that I'm going to use this space to quickly just sketch a graph. Right, the velocity time graph, the first thing you must have is to have the heading velocity versus time graph, and your graph should have should look something like this. Right, now since it depends on what you are doing, I've been taking downward motion as positive, so that means any upward motion is going to be on the negative. First thing I'm going to do is a time 0, which is our time 0 here. The object is released with a velocity of 4, we calculated it 4,2, so I'm going to go on the negative and put 4,2 seconds. That is where it is. Then it is released, it goes up, slowing down, and stops. And when it stops, it's stopping at time 0,42 seconds. Then it will carry on. So this will be our point X. It will carry on up to point Z. Point Z, remember the time, we said it's 0,85. That is when it is also going to reach again this velocity of 4,2, but this will be positive 4,2. Sorry, this is negative 4,2. This will be positive 4,2 meters per second. And let's put change in time here. So 4,2 also on the other side, then it will carry, do you see, in a straight line. It will carry on. This is what our graph is going to look like if we have taken downwards as positive. To those that would have taken upwards as positive, let me quickly erase this and then show you what the graph would look like. So the same thing, when we are drawing the graph, we need to have our heading velocity versus time, and a 0 there. This will be our change in time. This is our velocity in meters per second. So if we have taken upwards as positive, that means any movement on the upward is going to be on the positive side of the graph. So we're going to start with our 4.2 meters there, and then it will slow down and stop, and that time it's 0.42. Then it will carry on for another to get to 0.85 on our time, and then at that point it also is now at 4.2 on the negative side. Then it will carry on. That's what our graph would look like. Right, I hope this was very helpful and you have gained something